Welcome, everyone. It's really great to be at GDG Tucson. It's really nice to be a part of this Google I/O Extended. Thank you very much for being here, and also, well, hello from Norway. I am so for you, I think it's daytime. So good day to you. For me, it's getting quite evening. So well. It's what is it, 9 o'clock ish in the evening. So good day, good evening, good morning, depending on where you are in the world. So I would like to talk a little bit about developer nightmares. And developer nightmares is actually kind of relative thing because so what I'm going to be talking about is based on experience. So based on things that I've experienced myself working in the industry. I've been working as a developer, consultant, architect, and all of that for 15-ish years now. And so at some point, I kind of decided to put all those strange experiences that I've had and bad things that I've seen into a presentation. So that was how this talk was born. And then every time I do this, it kind of evolves a little bit. So I kind of decided to split this talk into two parts. So first, like I said, the nightmares and all this kind of experiences generally that we have with developing software, working as developers, is kind of relative. So I decided to split it in two, and I decided to do first give you a little bit of perspective, so move a little bit back in time and talk a little bit about the things that we considered kind of scary before, but or actually quite okay before, but they're kind of scary right now. To think about that, to do things like in that way, and then we'll talk a bit more into about what what happens today. So, like I said, the things I'm going to mention here is experiences from working in projects, on working on a really large project. So I've been working on mostly Java-related, Java platform-related projects, but it doesn't really apply to only Java. It can be any other platform as well. So this talk is going to be very general, more about development rather than about the platform. And the projects I've been working on are quite big. So it's usually at least 350,000 lines of code. So and that is like, one of the projects I used to be working on was around 400,000 lines of code. And back then, when we had, those spinning disks, it would take around 15 to 20 minutes to just compile the whole thing. And that was like with Maven and with all the other things. So when the SSD disks arrived, we bought them really expensive because they were just new and all those kind of things. So we got those and we cut down the build time in half. So it's just going from 20 minutes to 10 minutes. It was a huge improvement. But now things are a little bit different. But at the same time, it's not that many years ago. It's been probably, well, I guess around 10-ish years ago, or something like that. So the point is, projects usually that I've been working on are quite big. And I've been working in a very different roles in a project, both as a developer, as a tech lead, as an architect, even as a reviewer of some other projects, some kind of like due diligence kind of stuff. And, they invite you to have a look at the project and give your opinion whether it's good or things can be improved and so on and so on and so on. So then I decided to put all those things, both good things and bad things, but and create this presentation. So a few words about myself. So like you've heard, my name is Rustam. I am working for a consultancy company here in Norway called Compilation. I am one of Google developer experts on my GD for cloud, and I'm also a Java champion. So it's kind of similar thing to GD, just for Java platform. So the nightmares, and well, it can be actually, if you turn it around, it can be also a paradise, right? So I decided to, when I wrote down all those things, I kind of started grouping them together. So I kind of tried putting them into different buckets. And then I ended up with three main buckets of things with little small sub buckets, if you can call that. So this is basically what I ended up with. So developers' paradise, or the well-being of a developer, depends usually on kind of three main things, right? Obviously you have code, anything that related to your code. So it can be libraries, it can be tools, it can be architecture of that code, and all those kind of things. It can be tools that help you to manage all that, and documentation, kind of slightly forgotten child of all this, or part of this thing. It's not always, if you ask what makes you happy as a developer, people don't tend to mention documentation as on their first place, I guess. But so we'll be going into each part of that, each those three parts, and look at the different examples and things like that to help you a little bit with nightmares or paradise kind of thing. I have two little helpers. You can guess which one is which. So kind of a little bit scary looking zombie-like thingy, and a unicorn. In case you wondered, it's kind of embarrassing to say, but I ended up drawing those myself. So this is my creation. But I just needed something to spice up the slides and make it a little bit more colorful and a little bit more fun. So as a prompt, let's go back a little bit back in time and look into the 90s. So 90s is just before the time I started my kind of professional career. So mine started in early 2000s, but then I still have seen some of those things from the 90s still kind of leaking into the early 2000s. And also I even asked some of my colleagues, and I was like, look, I'm creating this talk. Can you please give me some examples of things that are kind of look scary and look weird and strange and so I got those. So this is a little bit of a mix of things. So if you talk about 90s, usually what you associate with 90s is the decade or the time of waterfalls. So really beautiful, really huge and enormous waterfalls. Not the ones that you see in the picture, but you know what I'm talking about, right? The software development kind of waterfalls. Where everything would happen in stages and there was no going back, and it would take ages to release something, and all that. And if we talk about the development part of the 90s, so we used to write. I mean, I was even when I was learning to program at school, or even at the university, I was still doing this. I was writing, for instance, Java, or it could be any other language in any editor, but it was not an IDE, it was editors. So it was notepads, Emacs, Vim. I mean, this is how I learned to love and slightly hate, well, mostly love Emacs. I mean, that was all my Java code for the first year or 2 years, something was written in Emacs. So, but in 90s, that was the kind of, this is how we did things. Right now, it would be, if you have to do that without all this IDE support and all the things that different various IDE platforms provide us, that would be kind of a little bit nightmarish now, right? Just I don't want to fix my import statements. I just want to do a shortcut and just auto-import things and just auto-indent things, and I can just control click on the method and follow into something, and all those things, they were not non-existent obviously in Notepad. I mean, I wrote my first web pages when I was at school, still in Notepad, and all those kind of things. If we talk about versioning in 90s, so that was also a kind of different animal. So and that thing I actually even ended up experiencing when I started working. My first job, my first few years at that place was actually I was forced to work with this. I mean, in case you have not experienced that, good for you. And just to mention, this is not the source safe that you know it today. Today is a totally different thing. So this was single file based with file locking and no multi kind of collaboration working together kind of versioning system. It was a nightmare of a versioning system, but that was the best that we had. So back then it was totally fine. If we had to do that now, or even CVS, right? You had CVS, you had SVN, you had, and then Git and Mercurial and all the other ones came in. So actually CVS, if you remember that was created in 1990. So in 90s, that was actually a brand new and fancy thing. And SourceSafe came in 94, just in case you wonder. So, right now, it's not as really, if you had to work with these things today, you would probably call that for a nightmare as well. Compilation and building of things. Oh, that was fun. And that was, again, something that I had to work with much, much later, probably in the second decade of 2000s even, where we had to compile our code. So you write your code in whatever you write it on, Notepad, Emacs, whatever. At some point, the IDEs came in, Eclipse, and all the other ones. But still, you had to compile them. I mean, there was no Maven. Maven arrived in 2004. In 2004, that was a brand new thing and did not exist. And that you consider like a kind of old thing right now, it just had a first release in 2000. So, this is 90s. This is before all that. You had to put all these class passes and everything into BAT files. And then you had to write kind of, Java and the command line things. And then you would end up writing BAT files that would kind of put all that together, put it into one liner and execute it and just compile the whole thing. So when I was working way into 2000s on a quite legacy project back by that measure, by that time already, I still had to debug things in the BAT files. We still had the spaghetti code as, the kind of the school book definition of a spaghetti code in the BAT files with go-tos, with all the, bells and whistles that were kind of really, really cool and hot back then. 10, 20 years later, that was not as fun as a developer. Another thing was, this is my favorite, because this is not mine. This is a story of a colleague of mine, because like I said, I asked him, I was like, can you give me some example of really weird things we had to do in the 90s, like the weird of the weird. And he was like, yeah, sure. We did issue tracking, like bug tracking and issue tracking, and we had to store it somewhere. So we ended up putting it into Access database. And I was like, yeah, I mean, I asked you for weird of the weird, and Access, it's not the the bleeding edge or anything, but so what? He was like, no, wait, I'm not done talking. So now I want you to imagine this MS Access, and in case you don't remember that beast, that was a part of Office package, and that was basically your own little database that you can have on your machine. So the database was local, and the problem with the whole thing was that that database file was actually stored not locally, but obviously to kind of encourage the collaboration and everything in a shared network folder. So can you imagine what happens when you open a database file that was made to be opened by one client and one client only, and put it on a shared network folder where you have no control about who and when edits it and opens it and closes it and so on. And and then you put all your issues into that thing. So what can possibly go wrong, right? Probably nothing. I mean, we sort of survived 90s, and things were fine. Things were, people were even flying to space way before that, way before all of those things, and it still worked, right? But if you think about all of those things are gone now. So now we move into uh, 2000s, so 2010, 20, and now all those things are gone. So now you probably should think that, or you would expect that, all those things are gone. So now it's just rainbows and unicorns, and it's just fantastic. Everything is just awesome. But as always, legacy projects happen. We always try and actually manage to find new things to, new ways to screw up and everything. So I I found this tweet some time ago. I mean, it's quite an old tweet, and it's just doing its rounds on Twitter over and over and over again with, like, certain periods of time between each round. But this is usually what happens. This is what usually happens to me when I get thrown as a consultant into a new project. And then you end up in a legacy code base and you try to understand that thing. So imagine, right, you have this 400,000 lines of code thrown over you. You're trying to understand what it is. This is your first day of the project. Obviously, after a few years, after some with experience and everything, you learn and you understand how to attack that gradual and eat that elephant piece by piece and all those things. But the first things you try to do, you try to understand it, to make it run on your machine, for instance, right? So you run tests. Well, there is no tests, or tests are way outdated, or totally outdated, or they even commented out, or they're non-existent. You try to read the spec. You have no spec. In this is I mean, this is obviously kind of the short Twitter version of that, but usually, again, what happens is that spec is there, but spec is written, or has been written by, around the time the project was created. And then 10 years passed and 20 years passed, and project evolved, and nobody bothered to update specs. Or they kind of did it a little bit here and there, so it's getting very confusing, or one way or another. So you try to write a fix, and eaten by an elder code hack, which is, it's all over, and all this fun comments. I don't know what it is, but it works, don't touch it kind of comments, and all these things that people usually joke with, but usually you actually, if you look good, if you look well enough and long enough, you'll probably find something like that in probably any code base. So that's another tweet that was also last year. And this is another side of this, because when you talk about these things, and you talk about the ways to improve all that, people that are not developers, people that are kind of on management roles and stuff like that, they don't really understand, why would you do refactoring of your code? Why would you actually spend time doing something that is not new features, that is not fixing bugs, that is not something that is visible to end user, but actually something that will make you feel better and a little bit warmer inside, and just what's the point, right? And this is another problem that we kind of face when we try to address some of those issues. When we try to say, hey, you know what, I'll update the documentation, I'll do this thing, I'll update the whatever, codes, and make the more test coverage better, or make it run, make it add some more tests to it and everything. And people would be, well, some, not everyone. It depends obviously on the maturity of the project and project manager and all the other things. But you probably have experienced this kind of thing at some point as well. So now we have a little bit of the stage, right? We have this thing that it's relative. Obviously, we've seen it was totally normal in the 90s, but it's kind of really scary and makes us lose our sleep. Today we had to do that, but let's go into this moving parts. So those three main parts of the developer's paradise. And usually what you'll see is that those moving parts and those improvements are being called different things. So before, well, some years before, it was very in to call it continuous something, right? Continuous integration, deployment, delivery, and all the other things. That was this thing. And that was kind of sold to you as a fantastic unicorn that will solve all your problems. Now it's being packaged also in, and rightfully, but it's being now packaged into DevOps and all these other things around it, and best practices and all the other things. But it doesn't really matter the way you call it, what you call it. In reality, it's some things that really needs to be done and needs to be considered when you develop projects or when you work on projects like that. And when that thing was called continuous, you call it whatever, CI, CD, CD, other things, so development, deployment, delivery, and integration. It was usually sold to you as a kind of one big rocket ship that will take you to the other planets, and make it fantastic, and everything's going to be cool. But my point is that all of those things that I'm going to be mentioning here, you can do any of them in any order and to any extent that you want, but you still will get to a point. There is this Boy Scout rule, right? That whenever you come to a project, try to leave it a little bit better than the way you found it. So the similar thing here, right? It's like no matter which of those things you do, and no matter to which extent you do, even just a little bit, you will make your project better. So you don't have to introduce full, from commits to production in no human interaction whatsoever in one go. You don't have to do that. A little bit of automation, a little bit of that, a little bit of this will make your life a little bit better. So, and gradually you'll move into this the paradise kind of thing, right? The palm trees, the sun, sea, all those really nice things that we kind of connect with summer and warm and vacation probably. I want to start talking a little bit more about development. So the first thing, the first part is this big chunk that I call code that you can still see faint on the side there. And it consists of several things. But first, I'd like to talk about code in general. So when I'm asked to do a review of a project, so what do I do? Where do I start? I mean, remember, you still have this, 500,000 lines of Java code that is scattered all around many files, many folders, many packages, many dependencies, and all these kind of things. And what I usually like to start with, I usually ask about the code quality. I ask a few questions to people that work with it. And this is also a very nice, actually, tool for you both as a new junior developer, but also as an experienced developer, no matter really what experience level you have. But the thing is, when you're getting into a new project, or if you're even if you're on an interview and getting interviewed for a position, you can ask things like that. I mean, you can dig around and understand which level of maturity as a development team, the team is there already. So what I usually do, I ask, I was not expected. So I have this fun thing. Now you've seen all of my slides probably. Really quickly though. There you go. So I have an arrow and I have end on my keyboard right next to each other. So can you guess what happened now? Yes, I did click on end. So I usually ask about code quality first. So I ask if the team has a code standard. I was like, do you have actually your code standard? I don't care what kind of code standard is, but I just want to know if you have one. I mean, are you agreed on, okay, we're going to have tabs versus spaces, or I'm not trying to start a new flame war, but one or the other, and so many spaces and curly brackets going to be there, and all those kind of things, import sentences, and all those things. And usually people say, people usually tend to say, yeah, well, yeah, we do. I mean, yes, we're using the standard thing that came with a platform that is best practice, or we've created our own that we edited a little bit, tweaked a little bit. And I was like, okay, cool. So my usually next question is, do you actually follow that code standard? And that's where people actually get a little bit more nervous. They would be like, well, I think we do. And this is usually a little bit of, if you can call it a code smell, probably. Because the thing is, people might have standards, but what usually happens with the big projects, people tend to tweak those standards a little bit because some things are annoying and some things are just, just don't fit your project and your way of doing things. And they end up tweaking that. And that's totally fine. But the thing is that they don't tweak it in a central place. They don't kind of sync those tweaks between each other. So somebody tweaks something, somebody else tweaks something else. But if I run this code standard on a build server that has one set of rules, that probably might break those rules. So that's one thing. The other thing we did on the project, just to understand how diverse the kind of the environment, development environment is, and code and everything is, we had a look at encoding. And encoding is a kind of dangerous animal because, especially when you're used to develop in English, and you usually kind of tend to work mostly with ASCII letters and characters and all the other things, it doesn't really matter that much, right? It's just probably going to work. I mean, that's usually the reason why encoding is still a big problem when it comes to internationalization and all the other things, because it's mostly developed in English-speaking countries, US mostly, and then the software comes to another country, and then you have to kind of handle weird letters like this. This is Norwegian letters. This is totally legit Norwegian letters. So you have those 3 extra letters in Norwegian alphabet, which is the one with the tiny A with a tiny little ring. But this A and E together, that's A, and the other one is Ö. So the one with the slash or slashed over O. And this is totally legit words, but if your encoding is off, if it's not UTF-8 or something else, this might cause some troubles. Usually it's just cosmetic troubles and will look a little bit weird, but not always. I mean, I've worked on projects where actually encoding created some really bad, nasty crashes and everything. And then you have a bit more probably letters that are a little bit less exotic than the country of 5 million speaks and uses. But you have, for example, this as in Spanish, for instance, right? But it doesn't matter. The point is, all those extra letters that are not typical ASCII thing, right? Another fun things, because this can actually cause some damage. So this thing, the MIME type, does not cause any damage. Most of the cases, it's not going to do anything, but it actually tells me a little bit, also a bit, about diversity of editors, because Java files sometimes are. So we did run this test. So we listed all unique encodings and unique MIME types, and then we had like 4 or 5 or 6 different encodings for files. Still 400,000 lines of code. And we had around 7 or 8 different MIME types, anything from C++ to HTML to text to all different weird MIME types. And like I said, MIME type doesn't really matter. It's not going to do any damage. But it actually tells me that the team that is working on this, they probably don't have a unified development environment. They probably don't have a unified way of doing things, which is doesn't have to be a bad thing, but it gives me a little kind of pointer of where I probably should dig a little bit deeper. Then the other thing that's kind of obvious, but I still ask and I still get shocked sometimes when I get to hear the answer, is the code reviews. So I would ask, like, do you actually do code reviews? Do you what's the routines? And sometimes people will say, yeah, we do that, and that's totally fine. And sometimes they will do it in person. Sometimes they will do it over digital tools. Each of those things have their positive, negative sides, and all the other things. But sometimes probably the strangest one I've heard was that, no, we don't do code reviews. I was like, why? No, well, we don't. I mean, we're just so been much working together, so we know each other really well. We finish each other's sentences, we finish each other's parts, pieces of code, so we don't do code reviews. And then I was like, well, that's fine that you do this, but this is not about that. This is not about knowing each other and finishing each other's sentences. It's actually trying to explain something that you thought was a good idea or you thought was the right logic, but then, that's why the rubber ducking concept even exists, right? You try to explain it to someone, and then usually you end up like, oh no, that probably was not that good idea. So you end up actually correcting yourself. It's not that somebody is going to correct you. So code reviews are actually quite a nice thing. I mean, it might sound quite obvious for you. If it does sound obvious for you, and that's a normal thing for you to do, please continue doing that. And well, nothing to see here. Let's move on. But if you don't, you might really want to consider doing that. This is a way of trying to make your code better before it hits the production, before it hits even possibly a versioning system, depending on how you do that. Right? So now I want to talk a little bit. Now we talked a little bit about code. Now I want to talk a little bit about development tools. So the tools that we use to create all the code version. We've been talking about that already a little bit. So we've heard about some weird and nasty tools that seems to be that now, but back then they were state of the art. But the point is, I'm not going to tell you which tool to use. There are a lot of tools. I mean, there are a lot of ways of doing that, but there are a few things that you should think about when you do that. And one of them is, how do you do branching? Because branching is going to be a thing that's probably going to hit you in any platform that you're going to use. I mean, if you're using Git, Mercurial, SourceSafe, anything that you'll be using probably has some kind of concept of branching. And how do you do that? How do you release new versions? What is your development branch, and what is your released version branch? What is your root branch? What's your main branch, right? And this is also an important thing, because there are different ways of doing that, right? I mean, is the thing that is right now in production, that is your main branch? Or if it is the development branch, that's your main branch, and then the other ones is kind of branched out from that one and tagged and finished. And how do you have to, when you have say you have one version in development, one version in production, and then you have to release, that's the easy way. I mean, that could be much worse when you have several versions going on, right? But let's say we have two, but then you encounter a bug in production. How do you patch that? How do you make sure that it kind of gets into development? And all those things are things that you should think about and go through and make sure that it actually makes sense, and you actually actively thought about it. Another thing when it comes to the development tools is that those tools are really, really nice to help you with things that we, as human beings, are not very good of handling. Is this thing that you see on the screen there is complexity. Because I mean, we can remember so many things at a time, and when you have to learn or remember new things, you kind of end up popping things from the stack and putting some other things in there instead. Computers do it much better, computers work much better with really mundane and complex tasks. So things like um, um, things like analysis of your code. So this is just an example of projects that are pulled out from this open version of a static code analysis tool, where I think this one is, what's that? That's test coverage, right? So things like test coverage, things like complexity of your methods, things like possible bugs, because those things like PMD and all the other ones, they can actually detect places where it's very likely to create a bug or to introduce a bug in the future, and some ways of doing that. That is probably not a very good way of doing that. So um, use those kind of tools to help you with that. Again, I'm not promoting any specific tools. I'm just saying find one, use one, and just make sure that it's being run somewhere central. And even it's actually a very good idea, because usually you will end up with some kind of dashboard like this saying, things are going up and down, and we have more bugs than last week and less vulnerabilities than last week. And, you'll get a grade or a letter for that. And they might look very different from what this thing is, but the point is, you will get this little bit of gamification kind of thing. So when back in the days when we were sitting in open offices and together and not at home, having this kind of thing on the screen would actually give you a little bit this feeling of gamification thing, where people would be like, oh, the arrow's starting to point down, I have to write a few more tests to bring it back up into the green zone, and all these kind of things. And people will just do that just because they just want to see green numbers on the screen instead of red. And and then you get better test coverage for free. I mean, obviously people have to spend time on it, but you don't have to make anyone doing it to do that. People just do it because they just want to do that. And like I said, it's going to show you in one way or another possible bugs, possible blockers and critical and major bugs, and different grades of that. And some of them will be fake alarms, or like false alarms, but some of them would be a real thing. So you have to see if you have to tweak the rules, if you have to ignore some of their messages, and if you don't have to do that. But still, it's a very nice thing to do that. So static code analysis, this is what we talked about, right? Another thing is that when it comes to development tools, because I mean, like again, we talked about IDEs. IDEs do a lot of things for us, but those IDEs, in addition to what they bring to the table as a standard, they have a bunch of really nice plugins. The versioning systems that we use has a really nice plugins. So I would like to put all that in just one big bucket called plugins, and just mention that, because all of those things that I mentioned, like, I don't know, static code analysis, or verifying that your tests run, and all of those things can be achieved with the plugins in one way or another. So there's Maven plugins, they can be IDE plugins, they can be your any other build system plugins, and really anything. Um, So just a kind of friendly reminder that those exist, and just have a look and try to see if there is something that's useful for you. But probably don't go overboard with those either, because you can go totally haywire and create a lot of plugins, and new versions will come in, and they will kind of entangle with each other, and you'll introduce more complexity than good as well. So be aware of that as well. So um, another thing that I would like to mention, and this is when I do this talk in audience with people in front of me, I usually ask people about this, and it's really, really fun. And I've done various versions of this talk quite a few times, and usually the results are very, 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 very similar. So I ask people if they know of all, or if they actually monitor their third-party libraries. I mean, it's not realistic to say that you should know all your libraries and what libraries you're using. That's crazy. Probably, I mean, I cannot ask people to do that, and this should not be like that either. But do you monitor them? Do you actually monitor your libraries for known issues and vulnerabilities? Because nowadays you have all those source code collaboration platforms and whatnot, like GitHub, GitLab, and all the other ones that will do the scans for you and actually alert you. But still, do you actually do that? Do you actively monitor your uh, vulnerabilities and your libraries for known issues? Another thing that I usually ask, and usually what happens when I ask this question, there would be, I don't know, in a room of say 200 people, 200 something people, there will be, I don't know, 10, 20 hands. So not that many, but still okay-ish. I mean, 10%, a little bit below that. That's that's bad, but not as bad, right? I mean, it's okay. But then I ask the next question. I usually ask, do you actually monitor your third-party libraries for licenses? And I'm not talking about licenses that you have to pay because, well, that's one thing, but also types of licenses in open source because some types of licenses they are um, tend to kind of impose that license onto your code when you use a library that's using that license, right? If you not do it in a specific way and so on and so on. But the point is, do you actually monitor the licenses of anything that you are using or anything that is being added? And now we have, out of those room of 200 people, and when we had around, I don't know, 10, 15 hands for the first question. For the second question, that would be probably like 3. And that is very, very bad. I mean, that would be really fun to do it again at some point when we'll get to meet again and to see if the numbers change. But for quite some time, the numbers were almost the same. There would be like 3 or 4 people working on really, really hardcore, super projects that need to kind of to have that handled, and usually that was imposed by somebody, and that's what they would usually say. But it is actually an important thing because one thing, it will can cost you money if you're using something that is commercial license and so on and so on. And sometimes things might have even dual license, right? So they can be used for open source projects. It's open source license, and for commercial use, it's commercial license. So that might cost you money and things. But sometimes it actually might impose the license on your project just because you used a specific library. And that might not be the thing that you want in your case, right? And there was a case when we were going through the libraries of a customer that asked to do a review of our code, and then we found some stuff that was GPL licensed, and I was like, "Are you aware of that? Technically, this can make your codes GPL licensed." And that was very critical code, not anywhere public or anything. I mean, it was nothing secret that way, but it was still code that they wouldn't want people to dig around in. And they got a little bit scared, but fortunately it did work out because it was done in such a way that it was okay. But it was not, it was more of a fortunate coincidence than actually a calculated thing. So licenses is an important thing, but just people tend to forget about that. The other thing is that, well, obviously, is the libraries you're using, are they actually updated, maintained? Are they compatible with each other? Because you might use a library and you might have been having it for like 5, 6, 7, 10 years. But if it's not updated, the bugs will be appearing, and bugs will be found, but will be people will be finding bugs in it. And if there is no one to update and maintain the library, there will be no fixes to it, and you probably won't even know that there is a bug or vulnerability in it. So this is a relatively old article, but that's more of a just to prove a point than actually to give you more updated stuff. I have an updated version of that in a few slides, but this is Google did some years ago. They did this a FizzBuzz of an open source projects, and here's the link, by the way. And then they found a lot of interesting bugs. So this is a classification of bugs, but the point is that there was a lot of bugs, and there was a lot of things that can go wrong in your project. And that was a very well maintained open source project. And the point is, we all create bugs at some point, and that's kind of how life is. So there is not that much we can do about it, except for the things that I've mentioned already, like automated tests and all the other things. But it will happen. But the point is that you need someone that maintains your libraries and your code as well, to patch all those, to address all those issues that are being found every day, every month, every week, every year. And so this is a newer version of the same thing, and well, it's a little bit of how it's been put together. But this is the kind of the main thing that I clipped from this GitHub page. So this is the same project that I mentioned, but just from 2021. So yeah, 30,000 bugs and 500 open source projects. Again, that is just a number, but just to give you an idea that bugs are there out there, and you need someone to maintain, and you need to keep an eye on your libraries, that those are being patched as well as your code. So yeah, there's more articles about things like that. There is also a number of vulnerabilities that are being found that is kind of increasing year by year, and at some point they kind of skyrocket. And there is more stuff and like about containers. So now we're moving a little bit more into even more this cloud native stuff where we have containers and things. And the same thing again. This is yet another place where the vulnerabilities can happen. So now you don't have to think about only your third-party libraries, but also about your containers or container images and stuff like that as well. More. I mean, there is a lot of articles like that. I just kind of put them together just to show you that there is a lot of them. So now I want to talk a little bit about different things. I want to talk about this trip your code makes from packaging or from a developer writing code and committing that code to running in production. So the whole thing of packaging, delivery, deploy, and all these things, is it automated or is it manual? You can guess which one is the preferred way, right? Automated is the thing, and you as little manual work as possible will make sure that you'll do things in the same way every time in all the environments. How do you deploy things? Do you deploy to all of your environments? Do you have the several environments? I hope you do. But if you deploy to all those environments, now we do all these things in the cloud, but we still have those environments, right? At least you have testing, at least you have production. Probably you have some development, and hopefully you have some kind of pre-prod staging, something like that as well. But how do you do that? How do you deploy that? And do you deploy it in the same way? There are a lot of tools to do that. I'm not going to tell you which one is good and which one is bad, but there's a lot of them. Pick one, use one, but just stay with something just instead of doing it all manually, because that's asking for trouble again. So when we talk about a code, there's another thing that we'd like to talk is architecture. And this picture is kind of it's nice to look at and everything, but it also tells me a little bit more of, I have this philosophical view of this picture of monoliths reaching to the cloud, and not an architecture like building architecture way, but like an IT architecture way, right? Monoliths into the cloud and putting it all into one container and pushing it to the cloud and things like that. But this is more of a philosophical kind of digression. Speaking of architecture, do your applications do they actually support continuous deploy? Can you roll out new versions continuously without downtime? Because this is how we do things now. This is cloud native. This is uh, age of cloud, and this is age of rolling updates and all these kind of things. Does your application do that? Do you want? I mean, and again, you don't have to do it all the way to totally continuous deploy, but try to improve it. Try to move towards all that. Um, the application architecture, how does it look? I mean, what packages and how those packages talk to each other, how those different parts of an application, and well, I'm thinking more of either it's a monolith with different parts that talk to each other, or it can be microservices with different microservices talking to each other. I still kind of call it as an application architecture and the big picture thing. Um, Integration architecture. Um, how do you actually integrate with each other? Do you have those? If things go bad, what do you do? Do you have some kind of backing off exponentially? Do you have failovers? Do you have all the other things? So that's another important point. Right? Code package structure is also an important thing. This is probably more important to developers that get to learn your code and to understand your code, but also it also is an important thing when it comes to introducing or fixing bugs. Because again, we don't really handle complexity that well, so we would like to have something that can be a bit more systematic, so we can understand it easier and grasp it faster, and so on and so on and so on. So, okay, let's talk a little bit about tools. So that was the code part and all those things that connected to code. Now I'd like to talk about more about tools kind of in general that makes all that code run more smoothly on wherever it's supposed to be running. First of all, I mentioned that a little bit already, but environments. So do you have your sandbox where you play around with things? Do you have your development? Do you have your staging? Do you have your production? All of those kind of things. It doesn't matter how many, but hopefully you have several of those. And the main thing is that do you actually have the same routines for deploy? Do you use the same routines from doing it in development till production? And that might be a bit tedious and might be a little bit overwhelming to do it every time in for development environment and so on. So maybe you need to modify that a little bit. But the point is, the more alike it is the way you do it in production, the more likely it is that you'll find all the bugs before they reach the production along the way. So you will be able actually to fix all of them before they end up in production. Are the environments similar? Are they actually as similar as possible? We've worked on projects where I got a bug report. It was a performance issue, a real bottleneck that would happen within, like, if you did this and this and this and this, you would get a really bad bottleneck. Everything grinds to a stop, nothing moving, no response time, no nothing. Everything is just spinning and nothing is happening. And then we actually managed to reproduce the whole thing from the production in our environment. We think we found the error. We found the bottleneck. There was some objects that have been created too many times, and blah blah blah. Changed a little bit of data structures, changed things, deployed, called the customer, said, "Hey, you know what? We fixed it. It's really amazing. We just did it in really in one day. Everything is cool. It just amazing performance now. We tripled the load and everything works fine, and it's fantastic. Customer gets happy. They are kind of they really want to deploy it as soon as possible. They deploy. Guess what happens? Nothing works. I mean, it's exactly the same way for them. With the same load, same kind of things, it just crashes everything. Why? Well, because our environments were different. So the bottleneck that happened in our environment was due to less RAM somewhere, less memory somewhere, less CPU somewhere, and we fixed that But the problem is on a server, the bottleneck was totally different place, and we had very hard time reproducing that because our environments were not similar. And I understand that having similar environments for all of your environments can be a very costly thing. So I don't say that you have to do that, but again, as close as possible. Right? Um, I'm not talking about your code, but now I'm talking about your environment. Is it rebuildable with, for hopefully, with just single script? With this new way of doing things, cloud native and all this cloud stuff, it's getting more and more normal to do that. But still, if your data centers is down for some reason, somebody have been digging and they just dug over the fiber optic cable, something happens, fire happens, anything might happen. And you need to move to another data center. Can you just like move a few files, start a script, and make it run for a few hours, and after all that, it just works? If you can, that's fantastic. If you can't, maybe you should start thinking to move it towards that direction. Again, you don't have to do it all the way, but as much automation as possible. Same physical hardware. This is not as big of a problem now when we are again moving a lot of things to the cloud. But again, we had some issues where we would run performance testing on our customers' servers on test environments, and we've been hammering it with requests. And what happens is that they call us and say, why you're DDoSing our production? And we're like, no, we're not. We're working on test. Can you check? Yeah, we checked. It's test addresses and everything, endpoints and everything. No, but our production is down because it's being basically DDoSed. So what happened actually was we were going against the right environment, but both of those environments would use the same storage. So when we hammered with requests on test environment, it continued with DDoSing the storage, SANs and everything. And then there was no time for the production to get any answer because, the storage was busier answering to all those performance performance testing things. So same physical hardware is less of a problem now, but still, that might be a very bad thing. Do you monitor all your environments? And I actually mean all of your environments because, again, like with the builds, if you automate builds in all your environments, the same thing with the monitoring. If you're monitoring them, you, at least as many as possible, you may not want to monitor the development where things go up and down all the time, but it depends on how you do things. But still, as many as possible, because again, you'll manage to see errors happening way before they hit production. That's another very nice thing. A lot of postmortems. There is a separate GitHub page out there that is listing all of them, and all of them are about mostly they are all about human errors. So the more you automate, the less humans will be involved and less error prone the whole pipeline is going to be. One more thing. Talking about tools and like using tools, right tools for the right job kind of thing. As you can see in the picture, that's a very interesting use of those tools. But in IT that happens quite often. But IDs. IDs is a fantastic tool. So I'm not, again, going to tell you which one to use, but just pick one and use one because it's very helpful and useful thing with all the plugins and things that we discussed earlier. Those are really nice to be integrated with different things like, running unit tests or static code analysis or any other things that you might want to have integrated with. Like, for example, common code standard as well that can be pulled from the server and just used on your ID as well. There are other things like I mentioned already, checks and commits. You can introduce that if you want to do that, if you need to do that. Again, don't overcomplicate things, but they're there. You can add some plugins into your, say, I don't know, Git or Mercurial or whatever you're using for version control. And build tools. So again, doesn't matter what you use, and use whatever you want, but still automate all that build processes as much as possible and use those that automation all levels. There's a lot of them. I mean, there's a lot of them. Some of them are kind of still live and kicking. Some of them are a little bit less popular now, and some of them there are new ones coming in and out, and there are cloud versions of things. But it doesn't matter. Pick one and stay with one. There is also, like for Java world, there is Maven and Gradle and all the other ones, and they are all for the other platforms as well. This is a very, very, very descriptive picture of how to choose a build system. I'm not going to go through that in detail, but still, I'm just going to show you that it's there. Take a screenshot if you want, but it's just a very confusing way of figuring things out. The point is, it's complicated, right? Anyway, last thing before we finish off for today is the documentation. And the documentation is actually a quite fun thing because it's not only just documenting things, because now we're agile and now we have this kind of collaboration over documentation, all these things. But it's still an important thing to do to collaborate with. You don't have to over document everything, but you still have to have enough documentation to get started, enough documentation to understand where to look for things, and so on, so on, so on. So that's where typically some kind of wiki comes in. So it can be Confluence, it can be wiki, it can be SharePoint, it can be whatever, but something that has this fantastic edit button. Again, my drawings that I was kind of trying to illustrate some kind of collaboration tool. But the point is that you have some kind of place to chat, to talk, and some place to share knowledge. And at the project where one of the projects that I was working on, I was like, do you have collaboration tools? Do you use something? And they were like, yeah, we do that. And I've been asking lots of long and difficult questions before that. So they were like, finally, like, yes, this is good. We can answer that. We can say yes to this. We can check that box off. And I was like, okay, cool. Which one do you use? And they're like super happy. And they're still like, on the up of this, self-confidence and everything. Finally, things that we can say yes with good consciousness and everything. They were like, yeah, well, you know what? We actually have two. And I was like, what? Yeah, we have two of them. And I was like, okay, this is interesting. I mean, the two is probably, you might think it's better than nothing, but can you imagine which one actually gets updated when things need to be updated, right? Think about it. Which one? Well, probably the correct answer is neither. And this is what usually happens, right? You have two, and there's like, well, which one do you update? Where do I go? Oh, well, I'll do it later. And this is what usually happens. So 2 is not good number. 3, neither is 3. So 1, but use it and kind of stick to it. So then another thing that we already mentioned a little bit. So this is again a drawing that I did. It's more. This one is a bit more of a bug containment system, but we are talking about bug tracking system more, right? So the same thing, I asked them, and I was like, do you have issue tracking? The same people. And they were like, yeah, we do. And I was like, let me guess, is it 2 of those too? And they were like, yes. And I was like, why? Yeah, well, because the customer is using one, development team is using the other one, and then there is a person in between that syncs them manually. Again, right? Think about the MS access in a network shared file, shared network folder. Kind of same thing, right? What can possibly go wrong? That poor person needs to sync all of that. And then I came crying to a colleague of mine, and she was like, look, that's not the worst thing that I've seen. I mean, the worst thing that I've seen was that where we had actually 3 different bug tracking systems, and all of those three had to be synced manually. And again, what can possibly go wrong? People do mistakes, and people do go on vacations, and people do sometimes quit, and what can possibly go wrong? So one issue tracking system, but still use it for all it's worth. And well, now we're kind of through. Now we're back to where we started. We have looked at those three different ways of doing things, and also, again, some of those things kind of going to be obvious to you. Some of those things that you already have in your project. Some of those things you might be thinking to adding to your project. But then the thing is, sometimes it's very difficult to convince someone that is responsible to saying go, no go to things to actually that's a good idea. And people very often when I do these talks, they ask me, like, hey, I want to do that. I want to introduce this, but they're always saying no. How do I do that? And my usually answer is gradually. So do it slowly, do it a little bit at a time, show the value to the people. It's like, hey, you know what? We have a lot of errors here. We introduced this unit tests for those problematic areas. Now our number of errors is down to like a third of what it was, or something like that. And then people will actually see the value of doing things that are not just like the user-facing kind of directive, right? And now when we've seen all that, and I called that different names, I called it continuous integration, development, deployment, and all those kind of things. I've also called it, I also referred to parts of what DevOps methodology or culture kind of points at. I want to show you at the end a little bit of what CNCF, or Cloud Native Foundation, actually says about what is cloud native. And then you will see actually kind of the same thing. Now, wall of text, I know that this is very bad. You should never show a wall of text on the screen, and you should not be reading that anyway. So I'll help you with this. I'll help you to kind of pull out the main words, and I'll help hide those words, the other ones that are not very important. But still, now you'll actually see all those things that we talked about and that we have mentioned here that are actually making our life much, much easier. So what do we want? Well, we want a scalable application that are able, don't have to, but able to run in public, private, or hybrid clouds. We want to put them into something that's containerized, using microservices and immutable infrastructure, and so on and so on and so on. And why do we want to do that? Well, because we want to do it loosely coupled. We want to have to be resilient, manageable, observable, robust automation, handle changes frequently, and also predictable, and obviously with minimal toil. And now we're actually getting to this rainbows and unicorns yet again. And if you do all those things, and like I said, you don't have to do all of them at the same time. You can actually do them gradually and a little bit at a time, a tiny little piece at a time, but still it will make your projects a little bit better and will kind of save you from those nightmares. And like I said, you can also use those questions and things in when you're actually vetting, like when you're vetting a new project, when you're trying to figure out if that project is for you, you can actually ask those questions and see what they say. It doesn't don't have to be in that thing. I've written a few things, a few blog posts throughout the years that might be relevant here. So this is where the command line tools that I've used to do this MIME types and encodings and all the other things that I put together. So this is kind of a little bit of a list of things. It's been a few years since I wrote it, but most of the things are still valid. So this is the link for that. There is a kind of a digest of what I've said so far that I've written some time ago. This has not been updated with the newest things, but still it kind of gives you an idea of what we talked. And this is me. That's where you can find me and ping me. So this is me on Twitter. You can email me. You can might DM me on Twitter or anything with it. So I have not seen I haven't been looking at the chat, but Yeah, that must have been brutal. Developing Java in a Vim, exactly. It was.
Yep. Yeah, there was a lot of reminiscing and a lot of comments like that.
Awesome.
And
That's
so it
exactly what I wanted.
so thank you so much. We did get a request. One thing that did come up is, and you just kind of shared it there towards the end, but could you provide some links for some of the resources that you mentioned? There's some things that, like OSS Fuzz, I hadn't heard of before. So um,
Yeah,
yeah, it'd be really great to be able to get some of those things if you could. Yeah, in fact, we just had a request for links and slides. If you'd be willing to share those, that would be
sure.
great. So
Sure, I'll share this. I'll send them to you. I guess you have some way of posting those in one way or another, or if I can just like I'll just put them on slide share or something like that. If
okay,
not, just ping me also on Twitter or anything. So all of those things that I use, they have links on top. So you should be able to track back to all this. All this. FizzBuzz is really fun project, but it's sometimes they do the visual presentation of things they find, but usually it's a little bit more digging that you need to do. At least last time
hmm
I checked, but it's still live and kicking. I mean, last time I checked was just a month ago, and still was like no, what was that, 30,000 bucks or something?
wow,
So yeah.
okay.
So any
Uh,
other comments that I may have missed because I kind of
oh, there were a lot. You started the VI versus Emacs war, and yeah, there are a lot of things
ah,
going on.
nice, nice, nice. That's exactly what I wanted. I didn't want to start a war though. I mean, I really like. I learned to like VI. So I started with Emacs and then I learned to like VI for a very practical reason because I couldn't exit it. No, that's a bad joke. No, because it's because it's installed in most of the servers and Emacs is not. So I kind of
Yeah,
had to learn it. But so now I'm kind of friends with both. Anyway.
yeah, yeah. That's how I got started with VI, is because that's what was available at the command line on the DEC machines that I first learned programming on. So what choice did you have?
Exactly. Oh, nice. I see a
Uh,
lot of comments. That's really great. I mean, it's amazing that you've been so live and chatting and commenting and everything. It's really really great. Thank you for giving me the opportunity to do this keynote. That's been really really fun.
Yep. Yeah. Thank you so much for being here. Really appreciate you spending your evening with us. I know it's getting late there in Norway,
My
so
pleasure.
thank you so much. Really enjoyed it. And again, thank you for being here. I don't see any other questions, just a lot of thanks and a lot of comments about small talk and VI and a lot of different things. So, yes, thank you so much.